You're standing on a treasure. Not the kind you see in pirate movies, a real treasure lying right beneath your shoes. Titanium is the 9th most abundant element in Earth's crust. If our planet were a giant pizza, titanium wouldn't be the rare slice someone already grabbed. It would be one of the huge pieces still sitting on the tray. So why does the price jump the moment a tech company announces a titanium frame?
Finally here.
As if it were coated in diamonds? Why is a metal that exists almost everywhere able to make the aerospace and medical industries spend money like they're booking business class tickets? It sounds absurd. But titanium isn't expensive because it's rare. It's expensive because it's incredibly difficult to deal with. And the story begins with a toxic romance between titanium and oxygen. In nature, titanium doesn't sit around waiting to be picked up. It mostly exists as oxides, meaning it's tightly bonded to oxygen. The most common titanium ores are ilmenite and rutile. They sound like villains from a sci-fi movie. But in reality, they're just very ordinary rocks. The problem is that titanium is deeply attached to oxygen. At high temperatures, most metals will separate from oxygen if you give them enough energy. Iron does it quite obediently. Aluminum too. Titanium, however, refuse. It clings to oxygen like it just watched a dramatic Bollywood romance. The bond between titanium and oxygen is so strong that you can't simply heat and hope. You need an environment that is almost completely free of air, because the moment even a little oxygen sneaks in, titanium runs straight back to its old partner. It will even react with nitrogen and hydrogen if you're careless. Imagine trying to cook a meal where the main ingredient keeps jumping out of the pot and running back to the supermarket. That's what engineers feel like when working with titanium.
No, look at the heat exchange. It's
Not
spiking.
because it's
the gauge
rare,
is
but
faulty.
because it refuses to cooperate. So humanity invented an industrial divorce. A process whose name already smells like smoke. Kroll. The Kroll process isn't gentle. It's more like marriage therapy, with fire. First, titanium ore is converted into titanium tetrachloride, a volatile, transparent, but toxic liquid. To make it, the ore must be heated to around 900 to 1000 degrees Celsius while chlorine gas flows through. What does 1000 degrees Celsius mean? It's hot enough to make steel glow like burning coal in a medieval forge. Hot enough that your eyebrows would disappear before you could say, ouch. At this stage, titanium temporarily leaves oxygen to bond with chlorine. But that's not the destination. The real tension comes next, reacting titanium tetrachloride with magnesium in an air-free environment. No oxygen, no nitrogen, almost a vacuum. Because if not, titanium will betray you again. The result is metallic titanium in a porous, sponge-like form, a material that looks like a burnt piece of foam. It's not shiny, not glamorous, nothing like what you imagine on aircraft skins or luxury watch cases. And here's the irony. The entire process consumes enormous amounts of energy. Every step demands extreme control of temperature, pressure, and environment. You're not just paying for titanium, you're paying for electricity, vacuum systems, heat-resistant equipment, and hours of tense waiting. What makes titanium expensive isn't hidden underground. It's written on the electricity bill. But if it's that difficult, why do we keep chasing it? Titanium has a very strange personality. Once separated from oxygen and existing as pure metal, it instantly forms an ultra-thin oxide layer on its surface to protect itself. This layer is only a few nanometers thick, hundreds of times thinner than a bacterium, yet strong enough to prevent corrosion. You can throw titanium into seawater. It won't rust. You can implant it into the human body. The immune system stays calm. It sits there peacefully, like a polite guest, about 40% lighter than steel, yet with comparable tensile strength. That means if you build two bicycle frames with equal strength, one from steel and one from titanium, the titanium frame will feel noticeably lighter the moment you lift it. In aviation, every kilogram saved translates into thousands of liters of fuel over an aircraft's lifetime. That's why titanium feels like the high-maintenance celebrity of the metal world. Not because it's rare, but because to invite it into the game. You must meet strict conditions, high temperatures, clean environments, unforgiving processes. It refuses to work under ordinary circumstances. And maybe that's the most fascinating part. Value doesn't come from scarcity. It comes from the effort required to tame it. The next time you hear someone brag about a premium titanium frame, you can smile. They're not showing off a rare metal. They're showing off a 1000-degree industrial divorce, a massive electricity bill, and a metal far too demanding to ever become truly ordinary.